For today's lesson, we will be using variables to write algebraic expressions. Our two standards are 6EE2A and 6EE2B, as well as 6EE6. So first, it's important to know the difference between an expression and an equation, and to know the difference between if it's numeric or algebraic. Numeric expressions and equations only use numbers. Algebraic expressions and equations must include at least one variable. They can include more than one, but they must have at least one. So an example of a numeric expression would be 8 times 6. You can also have 5 plus 9, 13 minus 7, 42 divided by 7. All of those would be examples of numeric expressions. A numeric equation would be something similar to 7 plus 4 equals 11. 15 minus 9 equals 6. 8 times 11 equals 88. 36 divided by 4 equals 9. Those would all be examples of numeric equations. For algebraic, we must use a variable. Variables are lowercase letters of the alphabet that stand in place of an unknown number. And most of the time you can use any lowercase letter of the alphabet that you so choose unless one has been assigned already. So an example of an algebraic expression would be n divided by 5. 13 plus k. 19 minus m. R times 4 would all be examples of algebraic expressions. And then an algebraic equation (32 minus k equals 13). 4 plus a equals 9. 6 times c equals 72. 44 divided by n equals 4 would all be examples of algebraic equations. One thing to notice with your expressions and your equations have an equal sign. Once you put an equal sign on, it is now an equation. And for an equation, you will also have the answer. In an algebraic equation, you would be able to solve and figure out what your variable represents. In an algebraic expression, you have to be told what the variable represents. So let's look at writing different expressions, both numeric and algebraic. So if we have a 5-inch ribbon, it's taped to an 8-inch ribbon, what is the total length of the two ribbons? Now you might be tempted to write 13 as your answer because that's the total length, but we are writing expressions. So our answer here would be 5 plus 8. With addition, you can switch the order, so another acceptable answer for this one would be 8 plus 5. Either of those is acceptable. For part B, scroll down here a little bit, we have a ribbon of unknown length taped to a 9-inch ribbon. What is the total length of the two ribbons? So first we would have to determine the length of our unknown ribbon, of the unknown length of ribbon. Well, since it's an unknown, we can't just put any number in. We have to use a variable. And since no variable has been assigned, we get to choose our variable. So let's just go ahead and start with one of the most popular variables out there, x. So the length of the unknown ribbon is x, and we're going to tape that to a 9-inch ribbon. So our expression would be x plus 9, or again, since it's addition, we can switch those around, and we could have an expression that reads 9 plus x. Excuse me. So a variable can be replaced by different values, which is why it's called a variable. It'll vary, it'll change depending on the situation. X is a variable, so it can represent different values. So if the length of the first ribbon is 12 inches, then instead of x, we'd put 12. If we were told that the length was 5, we would put a 5 instead of the x. And that'll be things we do in a future lesson. Well, here we have a straw of length 10 centimeters. It's cut from a straw of length 24 centimeters. What is the length of the remaining straw? Well, again, you might be tempted to put 14, but we are writing expressions. So instead of 14, you would put 24 minus 10 because we're taking those 10 centimeters off of the 24. Now with subtraction, you cannot switch the order. So if you had 10 minus 24, that would be an incorrect answer. Scroll down a little bit again. A straw of length 6 centimeters is cut from a straw of length y centimeters. What is the length of the remaining straw? Well, very similar situation to what we just have. We start with y centimeters and we cut off the 6. Now in this situation, we are told that it's y centimeters. So we would have to use y as our variable. In the previous example, we were not given a variable, so we could come up with our own. But if a variable has already been defined, you must use that variable. So a couple more examples here. We're writing algebraic expressions for each of the following. Well, for number 1, it says the sum of x and 10. Well, sum refers to addition, so you'd have x plus 10, or you could have 10 plus x. Number 2, the difference. Well, difference refers to subtraction, so you will be subtracting. We want 7 less than y, so we need to take 7 off of y, so that'd be y minus 7. For number 3, we know that Jim is z years old, and for part A, his brother is 4 years older, and we want to find his brother's age in terms of z. Well, if your brother is older, that tells you that you need to add 4 years to Jim's age. And for part B, his sister's 3 years younger. Find his sister's age in terms of z. Well, if they're younger, you need to take those years off. So Jim's sister would be z minus 3. We can also write algebraic and numeric expressions for multiplication. So if there are 12 crackers in each box, how many crackers are there in 2 boxes? Again, you might be tempted to write 24, but we are writing expressions, so that would be 12 times 2. And you'll notice in this situation that I am using the multiplication dot as opposed to the multiplication x. And we start to do that here because x can be used as a variable, and this helps us determine if it's multiplication or if we're using a variable. Just like addition, you can switch the order for multiplication. So another acceptable answer would be 2 times 12. So for part B, there are z crackers in each box. How many crackers are there in 4 boxes? Well, you could have z times 4. You could have 4 times z. Or another way that you will start seeing multiplication written when you have an algebraic expression would be to put those two together, and you could have 4z. Now, a couple things with this. Number 1, it has to be algebraic. You cannot write it this way with a numeric expression, and the number must go first. So you must write 4z. You cannot write z4. Just like the other operations, we can write expressions for division. A 12-inch rod is divided into 3 parts of equal length. What is the length of each part? So again, you don't want to write 4, but you'd write 12 divided by 3. You could also write division in the form of a fraction, or you can use a slash. A rod of length w inches is divided into 7 parts of equal length. What is the length of each part? So that would be w divided by 7, w over 7, or w slash 7. A few more examples here. Number 4, the product of z and 6. Well, product refers to multiplication. So you could have z times 6, or 6z, or even 6 times z if you so choose. The quotient of w and 8, well, the quotient refers to division, so that would be w divided by 8. And then number 6, Mia bought a pair of shoes for $P. She also bought a dress that cost 5 times as much as the shoes, and a belt that cost 1/4 of the price of the shoes. So for part A, we want to find the cost of the dress. Well, it says the dress costs 5 times as much as the shoes, so that would be 5 times P, or P times 5, or you could have 5P. We want to find the cost of the belt. Well, it says a belt costs 1/4 of the price of the shoes. And most of the time when you see the word of, that refers to multiplication. So you could take 1/4 times P, or you could use division. And in this case, you would have to divide by 4. So you can use division there, but make sure you're using 4 instead of 1/4. And if you're not sure how that works, I would suggest put 8 in for P and see what happens when you take 1/4 times 8, and see what happens when you take 8 divided by 4. Now up to this point, we've had expressions that have required one step, but you may have to write expressions that require more than one step. So when you do that, you just break it down into different pieces. So for number 7, it says divide m by 7. And then you'll see after the 7, there's a comma. Well, in reading, when you get to a comma, that tells you to pause. And we would do the same thing here. Divide m by 7. So we're going to do that first. But a comma also says, hey, you're not at the end of the sentence yet. You need to keep going. So we keep going. It says, and then subtract 4 from the quotient. Well, after we take m divided by 7, we would get our quotient, and then we would have to subtract 4. Something else that you can do on number 7, you could take that divide m by 7, and since it comes in front of the comma, you could put it in parentheses. Now those parentheses are actually not necessary, because if you follow the order of operations, you would do m divided by 7 first before you would subtract 4. But it doesn't hurt to have those parentheses on there, so sometimes it's better to be safe than sorry. Number 9 says the sum of 1/3 of z and 1/5 of z. So with the sum, we know we're going to have to add. Okay? And here it says 1/3 of z. Well, as we established, most times when you see the word of, that means to multiply. Now, the of that we have right here does not refer to multiplication because it's preceded by the word sum. But we have 1/3 of z and 1/5 of z. So we multiply 1/5 times z. And if we want the sum of those, we would add those together to get our expression. And there is today's lesson. As always, I hope this helps.